presentation on the development of a planetary rover with a mobile robotic arm. This is a ROS-based system with computer vision and SLAM technology for autonomous navigation. I am Preet Sarda. I am from Team Prometheans. The exploration of a planet or other celestial bodies is a fascinating feeling, and as technology improves and we find out that it is possible, everyone is curious to what's out there in space. So, us as engineers, we try to create new systems, new robots to be able to explore these celestial bodies. So right now we are trying to build a planetary rover with a mobile manipulator, which will help us in exploring another planet. So our problem statement is to develop an autonomous object pick and drop system with robotic operating system and SLAM-based edge computing for the purpose of planetary exploration. Our main objectives in this project will be to develop a rover which is capable of surviving in all weathers and on all terrains, then equipping it with a mobile robotic arm. Here we are using a 6 degree arm with 6 degrees of freedom, and also to incorporate a vision system so as to make the rover autonomous with regards to navigation and identification of objects. This project has four key components. One is a six-wheel drive rover, the other a mobile robotic arm with 6 degrees of freedom. Then we have ROS and Jetson Nano. Then we have our computer vision system for autonomous navigation and object identification. So starting with the rover, we currently are building a prototype. So we are using a DIY kit, which is a six-wheel drive. We are using skid steering to control the rover. The components in this rover will be a Pixoc. Pixoc is an autopilot which will send command signals to the rover so as to give it the direction and the speed. Then we have the motor driver. We're using a saber tooth with 32 amperes of output power so as to control all the six motors of the rover's wheels. Then the chassis, as I mentioned, is a six-wheel drive chassis. So we've already assembled the rover and we are able to move it using Mission Planner, which is a GCS, and then through Python using the DroneKit API, we moved the rover in a square using DroneKit, as you can see now. Coming to the mobile robotic arm, so right now we have a mobile robotic arm with 6 degrees of freedom, as I mentioned earlier. So this makes it easy to move in any direction and maneuver in any place to for exploration and drill holes to pick up objects and so on. So the components in this mobile robotic arm, we are using six motors. NG995R are the servo motors which we are using. For now, we only have a gripper as the end effector. So we are using a servo driver PCA9685, which is a 16 channel PWM servo driver to control all these six motors. And we'll program the servo driver using our Jetson Nano, which is basically the brain of this entire system. So, and later on, while creating a scale model, we also have an idea to incorporate multi-purpose end effectors such as a drill and other things. Coming to the next component of the system, ROS and Jetson Nano. So ROS, which is Robotic Operating System, is basically an open source set of tools, software libraries, which are made for robotic applications. It helps us a lot in this project. So everything is based on ROS. Every communication protocol is being made through ROS. It provides an easy way to get the components together and communicate in between components. We have the robotic operating system is running on our Jetson Nano. It is a small but really powerful GPU which serves as the brain for this project. So we will be implementing computer vision algorithms for autonomous navigation and object pick and drop using our Jetson Nano. Into computer vision, this part is the one which we now have to figure out. We're done till assembly of the rover and the robotic arm, and we're able to move the rover and robotic arm together. So for this, we thought of incorporating a lidar sensor and cameras, and we'll have an AI model and use SLAM technology on the lidar to autonomously be able to navigate the vehicle. We are looking at Google Cartographer as of now. So this was an overview of our project and our progress. So we're hopeful of creating a scale model once we're done with computer vision on the prototype and actually be able to explore planets.